Okay, so this is the last lesson in the unit, and actually it's a really great lesson because really it's a review in itself. So we get to look at all the different types of transformations we've talked about and put them together into questions where it'll require more than one transformation. So to start with, let's just review what each of these letters represents. So we know our A value is our vertical stretch along the x-axis. We know if we have a negative A, then that would mean a reflection along the x-axis. B is going to be a horizontal stretch. By a factor of 1 over b, right? You always take that reciprocal along the y-axis. A negative b would mean a reflection along the y-axis. Okay, and then h is going to be a translation left or right. And K is going to be a translation up or down. All right. Okay, and then I'm also going to show you mapping coordinates. So sometimes that's helpful for kids. We're going to be using mapping coordinates a lot in this lesson. If you were to try to transform a graph and you had multiple transformations, you're going to end up, it's going to be a lot easier with mapping coordinates. If you try to do each transformation at a time, you end up trying to draw the graph 2, 3, 4 times. With mapping coordinates, you only have to draw the new graph once. Okay, so we've talked about how anything outside of that f function brackets affects the y variable. So I'm going to have ay plus k. Anything inside of those function brackets affects the x variable. So I'm going to have 1 over b x plus or minus h. There we go. So those would be the mapping coordinates to go along with the letters. Okay, so I'm going to erase this here just to provide myself with a little bit of space. Okay, so the first thing I want you to notice about your transformation equation is that it's in factored form. So whenever we're trying to apply that transformation equation, we need to make sure that the equation we're looking at is always in factored form. So we are going to go ahead and factor out a 4 here. Okay, so now let's describe the transformation. Again, you need to describe in detail. You will lose marks if you're not describing in detail. So 2 is my A value, so I have a vertical stretch by a factor of 2 along the x-axis. 4 is my B value, so I have a horizontal stretch by a factor of 1 over 4 along the y-axis. Okay, and then I have my translation, so I'm translating 1 left, right, because it's always opposite the sign, and 2 up, which is here, my K value. Excellent. So the next question says, f of x is transformed using the coordinates 2x plus 2. Okay, I'm actually going to backtrack back to this last question because I really want you to practice writing mapping coordinates. So if we look at the question we just did, to write the mapping coordinates, we would say, again, anything outside affects the y. So we have 2y plus 2. And then my x would be 1 over 4x minus 1. Okay, just another rule of thumb. Your mapping coordinates will always be the same as your description. So the only time you flip signs or you write reciprocals is if you're going from that function transformation equation. Okay, so I'm going to erase this so that I have a little more room. And then we'll try this next question here. So it says f at x is transformed using the coordinates 2x plus 2, 1/3. So again, because we have the mapping coordinate, we're going to describe the transformation and it's going to be as is. The mapping coordinate is always directly how you would map the graph. So it's exactly as it looks. So that means this 2 here would just be or a horizontal stretch by a factor of 2 along the y-axis. Notice how we don't take the reciprocal, right? We only take the reciprocal if we're working from that transformation equation, okay? And also notice, even though it's 2x plus 2, you do not factor 2 out, right? It's always as is when you're looking at mapping coordinates. Okay, and then my plus 2 means I'm going to translate the graph 2 units, right? Again, as is, you're not flipping the sign here. Okay, the 1/3 means I have a vertical stretch by a factor of 1/3 along the x-axis. Excellent. All right. So now just to keep practicing, because I want you to feel comfortable going from description, mapping coordinates, and transformation function equation. You should be able to go back and forth between those 3. If I wanted to write a transformation function equation, it would look like this. My a value would be that vertical stretch, which is 1/3. Your b value would be the reciprocal of the horizontal stretch, would be 1/2. And my h value, because I'm moving 2 units right, I'd have x minus 2. So this would be the function equation for that problem. Okay, oh. Next slide. So it gives us a graph. Each box on the grid below is assumed to be 1 by 1 graph. So the first thing I want you to do is I actually want you to try and write the mapping coordinates. Okay, because it would take forever if you were to try to do all of these transformations one by one. So just go ahead and write the mapping coordinates. So this negative here, that would be my a value. So that means I'm going to reflect along, and actually I'm going to write the description too. So it's going to reflect along the x-axis. The 2, remember, that's the reciprocal, that's your b value. So I'm going to have a horizontal stretch of 1/2 along y-axis. And the -5 just means I'm going to move 5 units down. Okay, remember our trick. Anything outside of the function equation affects the y. So that means we're going to have a -y minus 5. Okay, anything inside of the function brackets affects the x. So I'm going to take the reciprocal of that b value. So I end up with 1/2 x. So these are my mapping coordinates. The reason mapping coordinates are so helpful is you can take any ordered pair from the original graph, apply them to those mapping coordinates, and you'll get your new ordered pair on the new graph. So let's start here. So my original graph, I'm actually going to write this down here. My ordered pair would be 1, 2, 3, 4, 5, 6, -8, +4. So all I do is I input that -8 into my mapping coordinate. So I have 1/2 -8, and then the 4 as well, -4 minus 5. So once I input it, I end up with an x value of -4 and a y value of -9. So I can map my new coordinate. Great, and then I'll keep going. So my next point, -6, negative 8. Okay, so once again, I'm going to apply those to my mapping coordinates. So I'll take 1/2 times negative 6, and then negative 8 minus 5. And I end up with negative 3 and positive 3. Okay, so if I map my new coordinate, and again, as I'm mapping each coordinate, I'm going to connect the dots so that I don't forget which dot goes with which. Okay, my next ordered pair is right here. Negative 4, negative 4. So if I apply them to the mapping coordinates, my new ordered pair should be negative 2, negative 1. So right down here. And then the last point has an original ordered pair of 4, negative 4. So if I apply those to the mapping coordinates, I end up with positive 2, negative 1. Great, so that's my new graph. And from here, you could write your domain and range of this new graph as well. My domain would be from negative 4 to positive, oh, I can't even read my graph now. It looks like positive 3. And then your range would be from, looks like it goes all the way down to negative 8, or negative 9, sorry. And then the highest point is positive 3. There we go. Okay, and then we're going to jump ahead to this question here. So this is an old diploma question. What I want you to do is I want you to read this and then see if you can come up with the mapping coordinates. So we have below the following graph is reflected in the y-axis. So if it's reflected along the y-axis, that means our x is affected. Okay, it's vertically stretched by a factor of 2, so that's my y. Horizontally stretched by a factor of 1/2. And then translated 3 units up. So this is what the mapping coordinates will look like. Just to practice, let's write the function equation so that you can see the difference. So my a value, my vertical stretch is 2. My b value is going to be negative 2, right? Because I take the reciprocal of that 1/2. And then 3 units up. So that's the difference there. All right, so go ahead and try applying all your points. And I'm just going to draw the graph so you know what it should look like, but I won't go through each individual point just for time's sake. So your new graph should look like this. Oh boy, looks like there we go. All right, so around there we go. Okay, so it says the transformation of the equation x cubed is described by the function notation, by the mapping coordinate. Describe the transformation. So if these are my mapping coordinates, it just means my graph's going to go 2 right and 5 down. Because remember, it's always as is, from your mapping coordinates as is. You don't flip signs, you don't take reciprocals. Okay, if the mapping notation was 2x plus 2, describe the transformation. So this 2 would mean I have a horizontal stretch by a factor of 2 along my y-axis. This 2 here would mean I'm translating 2 units right. Okay, and the 1/2 would mean a vertical stretch by a factor of 1/2 along the x-axis. Excellent. All right. Here it says the graph of f at x equals x squared is below left. The function g at x is stretched below right is a transformation. Determine the equation. Okay, so when you look at this graph, notice how when I go down 1, I go up 1. But in this graph, when you move over 1 from the vertex, you end up going up 2. So in the original graph, when I moved over 1, I went up 1. In the new graph, when I move over 1, I end up jumping up 2. So that is, you actually could look at it as either a vertical stretch or a horizontal stretch. I'm going to see it as a vertical stretch of 2. Okay, and then we do notice a shift in the vertex there. So we are going to translate this graph. So if you look at the vertex, it started at 0, 0, and now it's at positive 2, negative 3. So we're going to say the graph moved 2 right and 3 down. Okay, so if we want our new equation, I'm going to write the function equation up here just to show you the difference. So my a value is my vertical stretch. I'm moving 2 units right and 3 down. So it looks like that. So this is my transformation equation. Now to get my new equation of the function, I apply it. So what this means, it all goes back to function notation. Okay, you're taking the 2 goes on the outside. But this function equation means you take that original equation and you replace the x with the x minus 2. So then I end up with x minus 2 squared. And then I just tack that negative 3 on the end there. Okay, so that goes back to function notation. All right, here's another diploma type question. So it says the graph of y equals f at x is transformed into the graph of g at x plus 1 equals negative 3 f at x minus 2. The domain and range of each function is shown below. Complete the chart by filling in the domain and range. So what we're going to do is we're going to, first of all, we'll rewrite this equation to isolate the g of x, which means we'll have to move that 1 over to the other side. So it becomes a minus 1. Now we're going to make mapping coordinates from here. All right, so we have x plus 2 is my x value. And then my y value is negative 3y minus 1. There we go. Okay, so for my domain, remember, these are both x values. So this is not an ordered pair. It's your domain written in interval notation, right? So they're both x values. So you're going to apply both of them to the x mapping coordinate. All right, so negative 1 plus 2 gives me positive 1. And then 3 plus 2 is positive 5. So my new domain should be 1, 5. Now my range, right, those are both y values. So I'll apply them both to the y part of my mapping coordinate. So 2 times negative 3 minus 1 gives me negative 7. 6 times negative 3 minus 1 gives me negative 19. All right, here's another diploma question. So it says, the ordered pair below represents possible transformations of the point P, A, B. If y equals f at x undergoes the following single transformations, identify the coordinates of the corresponding point P on the new graph. Okay, so let's start with A. That's an a value. Remember, anything outside of your f function is going to affect your y. Always go back to that, it'll help a lot. Okay, well, especially when you're dealing with mapping coordinates. So that means I'm going to end up with a negative b, right? Because my y ordered pair is affected. So that's 0.3. Okay, here That is inside the bracket, so it's going to affect my x. But remember, that's a b value, so you need to take the reciprocal of that 1 over 4, which is just 4. So I end up with 4ab. So that's 0.1. The next one, that's outside the bracket, so that's going to affect my y-ordered pair. So I end up with 1 over 4b, which is 0.4. And then lastly, that's inside my bracket, so that's going to affect my x-ordered pair. So I end up with negative ab, which is 0.2. Okay, so given y minus k, which coordinate is the vertex? So